Welcome to this demo, where we will show a snippet of how nodes can securely obtain certificates in the edgeless architecture. These certificates will allow to uniquely identify each node and use this identity for secure communication. First, let's take a look at the standard behind this authenticated registration process, ACME Device Attestation. ACME stands for Automatic Certificate Management Entity. It is a protocol designed to automatically grant and renovate certificates to whomever can solve a particular challenge that the server presents. On the other hand, device attestation, also called remote attestation, is a security feature that allows for a device to prove its identity and system integrity to a remote party. This can be achieved thanks to the TPM, which is able to provide a root of trust using its special registers and pre-provisioned keys. Let's now look at how the ACME device attestation challenge works step by step. For a device to obtain a certificate, first it must register an ACME account with the certificate authority. If the user provides the right information, it will be registered successfully and a resource will be created for the user's challenge. The user triggers the process by ordering a certificate to the CA, which will promptly return a challenge to the client. Using this challenge plus the attestation key from the TPM and other identifiers, an attestation statement is generated. If this attestation statement has the values as expected, both in content and format, then the challenge can be validated and the certificate signing request from the user can be signed by the CA. Let's now focus on the hands-on demo. First, we will check that the device has the Integrity Measurement Architecture module activated in the kernel that will provide integrity measurements relying on the TPM. We can also check that the TPM is working correctly by making it do a simple task like generating random data. For this demonstration, we will be using an ACME certificate authority from Small Step. It has been modified to fully accept our attestation statement. The configuration file is shown here. At the topmost, the root certificate and key information are added to be able to sign client certificates. To increase security, this CA will only accept ACME challenges as requests for certificates, and particularly only the device attestation 1 with the TPM format. The process explained can now be seen here in action. First, the Docker container for the certificate authority can be started. Do note that, to make this demo easier, both CA and client will be run in the same device. The configuration used in this case only allows for devices to get a certificate if they can successfully finish the device attestation challenge using a TPM. As it can be seen when a random request is sent, the client does not answer to the device attestation challenge correctly, so the process is stopped. If now we run the client that was designed, it will be able to correctly answer the challenge and obtain a valid certificate. This process takes a couple of seconds, depending on the time that it takes for the TPM to generate the necessary data. Its duration is capped at 1 minute, so that resources are not clogged by one device. In this case, it has been signed by the edgeless CA, and it will be valid for a period of 24 hours. That is the process of how ACME device attestation is used in edgeless to obtain a certificate that is linked to the device identity, increasing the security and trust in the architecture for both developers and end users. Note that this protocol does not establish how the attestation of the device should be done, and that it only checks the challenge and the format of the attestation statement. Therefore, it is possible for nodes with compromised systems to obtain a certificate and gain access to the architecture. To avoid such a scenario, a custom attestation certificate authority and corresponding client are being developed, where this information will be thoroughly checked before the ACME challenge can start.